Well, this one looks like a nightmare, doesn't it? Inverse tangent? What are we getting into? Implicit differentiation, I suppose, is just so fun. I'm going to give you a little tip here. I'm bringing this in. The derivative of inverse tangent is this, 1 over 1 plus x squared. Why am I showing you this? I'm going to make sure it's separate a little bit from the problem. Because we derived it like 2 videos ago. I'm going to put a link to that in the description because it's fascinating how we get there. It actually is. And I know math isn't always fascinating and you're probably not that interested, but it is. Okay, so let's actually utilize it instead of deriving it. Let's do a real problem here. This is going to be a chain rule because we have a function with an inside function like that. And remember that y is not a variable. It's not like a c or an a. We use y when we want to talk about a function of x. So that means that when we take the derivative of y, you don't get 0 like you do from a number. You get dy dx. And that's what we're looking for here. So the inverse of tangent being 1 over 1 plus x squared, let's just apply that same thing here. Except it's not x to us because the input was x squared y. Remember, this is a placeholder. It's a formula that says take whatever the input is and put it here and square it. Well, for us, that input is this. So that's what we're doing. And then we're going to square it like that. But we also have to multiply, chain rule, the derivative of the inside. And this inside is a multiplied group, so we're going to have to do product rule here. If you know the product rule, you should by now, it's u prime v plus v prime u. I like to write it right up on the top here. So u prime is 2x, v is y, plus v prime, which is dy dx. And that's what we're looking for, right? We're looking for dy dx through implicit differentiation, and u, which is x squared. Okay, and that's equal to the right side, which would be 1 plus, there's another product rule, u prime v plus v prime u. And u prime is just going to be 1, and v is going to be y squared, plus v prime, which is 2y dy dx. Don't miss that. And then u, x, like that. Okay. Why is this like this? Did you ask that question? Remember, the y squared is your outside function, and the y itself is a function of x. That's the inside function. So outside function times inside function. All right, let's move to it. Basically, it's a clear out, right? We want to get to dy dx, which we have in a couple of places. So I think what I'll do is I'll try and write this out separate and see if we can't come up with it. Let's multiply this up to the other side of the equation since he's kind of free-floating. And let's try and move anything that's not a dy dx stays, and let's try and move the dy dx's over to the left side like that. That's what I'm going to try. So first things first, I'll write this out a little bit nicer. We'll do a 2xy plus, looks like it's an x squared dy dx equals 1 plus y squared plus 2xy dy dx times 1 plus x to the 4th y squared. Let me just double check this for a minute here. I think that's correct so far. So should we FOIL this? That feels painful, but I think we have to. So that would be 1 plus x to the 4th y squared plus y squared. So the order I do this real quick is I go like this. These two, and then these two, and then these two. So that would be y squared plus x to the 4th y to the 4th plus 2xy dy dx plus, that would be an x to the 5th, wouldn't it? And a y to the 3rd. So we'll call it 2x to the 5th y to the third dy dx. And let's subtract this over, why not? Minus 2xy is equal to x squared dy dx. Did a lot on that step, but I think we're okay so far. Let's take these dy dx's and move them off to the left side. So I'll say dy dx x squared, I'm putting it this way for a reason, minus, well, I don't like that. We'll just call it x squared dy dx like it is above, minus 2xy dy dx, that's this guy, I'm just crossing it out for my benefit and keeping track here, minus 2x to the fifth y cubed dy dx, so this one's gone, equals 1 plus x to the fourth y to the fourth, highest exponents, plus x to the fourth y squared minus 2xy, now let's do the y squared, plus y squared minus 2xy. Did I miss anything? There's a y squared, a 2x, I think that's all of them. And we will factor out and divide. So I say dy dx equals 1 plus x to the fourth y to the fourth plus x to the fourth y squared plus y squared minus 2xy divided by the factor from this left side here, which would be x squared minus 2xy minus 2x to the fifth y cubed. So it's ugly, but the process is pretty straightforward. And that's your answer.